Hello and welcome to Gilli Pong Analysis. Now, we are checking, what was her name? Oh, Hartlich Hout. Sabine Hossenfelder again. Now, this is a 3-week-old video. The last one was a pretty old one, I think, 3 years old. But we're just gonna go into it a little bit because there was a black hole singularities, faith, not science, prominent physicist claims. So they found out Hawking was wrong. And we're gonna go a little bit of a deep dive because she mentions a few names here. It's very interesting because Hawking is recently in the news for having attended an orgy on the island of Epstein. And makes you question a little bit about the people who he is surrounded by, because my girlfriend is working with people with severe disabilities, and the poor guy seems to be in that position. So it's not Hawking we're talking about, it's the people who are wheeling him in, so to speak. But anyway, in this let's Sabine give us an intro into this whole thing.
This is the maybe most surprising development in theoretical physics I've seen for a decade or so. A well-renowned physicist is saying that there's a mistake in a proof that dates back half a century, and black holes might not actually contain singularities. The physicist in question is Roy Kerr, who's famous for his contributions to general relativity. He was the first to understand how to mathematically describe rotating black holes in Einstein's theory. Prior to this, physicists only knew how to describe black holes that sit still. But in reality, when you have matter that
we're talking about equations, about a concept. They're still debating if this is true. That's how far out of the track I think physicists in general are. Because physicist used to be something physical. Like, you could touch it, you could feel it, reality, right? So, this is about black holes and singularity, which Brian Cox, if you may remember, was talking about as a sure thing in one of his BBC videos.
Undergoes gravitational collapse, it'll generically have some angular momentum, and that angular momentum is conserved, so the final black hole must be spinning. If you want to describe real black holes, therefore, you need the mass to describe their rotation, and that's what Kerr managed to do. These rotating black holes are therefore also known as Kerr black holes. Black holes are characterized by their horizon, which is the surface of a region that you can only get in, but not out. I just explained in a recent episode on time travel that Kerr black holes are incredibly weird, because they have two horizons, and it seems that between them you can actually go back in time. Whether that's really possible or not, no one knows. But it shows that we don't really understand these solutions.
No,
besides the horizon, black holes all have singularities inside, also, we thought.
Yeah.
The singularity is a place where the curvature of space-time becomes technically infinitely large. With this, tidal forces become infinitely large, so everything will be ripped apart as it approaches the singularity. The horizon itself does not have a singularity. Now, in the early days of general relativity, some physicists said that black holes are mathematical artifacts. They can't exist in reality. Then Stephen Hawking and Roger Penrose said, no, it's the other way round. When matter collapses, it's impossible to prevent black holes from forming, and they all must have a singularity inside.
So they all must have a singularity inside. Okay, here's a beautiful picture of Hawking. So Hawking wrote like all these books, like 2 pages. There's also a like a game you can play, or it's a bundle of books. George Secret's Key, so some of them are maybe duplicate, but you can see how many books he wrote. And it's all done like, just watch this.
Does not preclude a creator.
I travelled to the Department of Applied Mathematics and Theoretical Physics at Cambridge University to speak with one of the world's greatest living minds. First off, congratulations on being the first subject of our Great Mind series. Be honest, is this the single greatest honour you have ever received?
Yes.
Good. It's a little hard to read your tone of voice. When you say that, are you being sarcastic?
Yes.
I thought so. If there is one thing you want people to understand about...
Some might say that's a sign of consciousness, a smile. We have a test of the... There's like a noise from alarm system in Oslo, it seems. That's what I was hearing behind the scenes here.
Bearing in mind that most people will never understand anything about your work, what would that thing be?
Imaginary time. People think it's something you have in dreams, or when you're up against a deadline. But it's a well-defined concept. Imaginary time is like another direction in space. It's the one bit of my work science fiction writers haven't used, because they don't understand it.
It's like a gig. Nobody understands him. He's so smart.
Idiots.
Idiots.
Such idiots.
Exactly.
Presumably, to my mind, you're simply talking about the theoretical measurement obtained from real time by a wink rotation of pi divided by 2 in the complex plane where t equals I times t. It's not that difficult to get your head around. Let's talk about artificial intelligence. In a recent op-ed...
But this is this guy. Poor guy. Like, here's a scripted, humorous joke where he's taken, and you know, South Park has been making fun of this kind of deal, you know. But there's also another guy here we have looked into, and it's Sir Roger Penrose. And there is an article out there. Like, what kind of research did sex offender Jeffrey Epstein like to fund? And he told Science, this is science.org, about it. And Jeffrey Mervis met him. Just an insight into how that started. In August 2017, I received an email from a publicist, Masha Drokova, asking whether I wanted to interview her client, Jeffrey Epstein. I saw her piece on President Donald Trump's science budget, she wrote, referring to a story on the president's proposed massive cuts to research in his 2018 budget request to Congress. Jeffrey has an interesting perspective on what it will take to fill the gaps. Would you like to speak with him next week? And then, what's his name? Jeffrey Mervis, talking to Jeffrey Epstein here. Why would Science talk to a shadowy financier and convicted offender? I queried my editor. How strange, one said. Wonder why he's seeking press now, another asked. Eventually, we decided I should accept the invitation, and on the chance that Epstein would say something newsworthy. Alright, this is a long article, and it's basically an interview with him, and he is talking about these things, and he's putting on some charm, and he's like, you kind of get to analyze that this guy is a very shifty dude. But all the way to the bottom here, Mr. Penrose pops up. And Jeffrey Epstein says, so I was just with Roger Penrose, a distinguished theoretical physicist who leads an Epinomic Institute in San Diego, California, and Roger told me about an Indian woman physicist who has come up with the idea of using Bose-Einstein condensate, a collection of supercooled atoms, to find gravitational waves. Okay? And Eve Fuentes is the one she is speaking of, I believe. Let me see. Yeah, I'm 100%. Eve Fuentes is a physicist who works with detecting gravitational waves. Penrose describes to Epstein. But unlike Bach and Lloyd, Fuentes says Epstein's name immediately raised a red flag for her. For the record, Fuentes grew up in Mexico, not India, and did her PhD at Imperial College London. So that's why her name is Eve Fuentes, and she's said to come from India. Penrose and Epstein had met at a June 2017 conference on the science of consciousness in San Diego. Although the topic of consciousness is not what I do, when I saw the list of speakers and was offered a plenary talk, I decided that it would be a good thing for me and a good audience to hear about my experiment, says Fuentes, a professor at University of Nottingham in the United Kingdom whose work is supported by Penrose Institute. Shortly after returning home, Fuentes says she and Penrose had a conversation. Would I be interested in receiving funding from a wealthy man who had also been convicted of a sex offense? Fuentes recalls Penrose asking her. Fuentes immediately said no, citing ethical objections, and quickly forgot about the conversation. About 2 months later, or 2 months ago, I say, which is, when this article is written, 2017, after reading that Epstein had been arrested, she called Penrose. Was it Epstein? She asked him. And he said, yes, I think it was. And I said, oh God. So, Penrose is being funded and delegating money from Epstein towards other scientists when it comes to funding these projects. It raises red flags in my mind. I don't know about yours, in my heart, but let's continue.
Famous Hawking-Penrose singularity theorems. They should have both won a Nobel Prize for it. Unfortunately, Hawking died before that. Penrose got the Nobel Prize in 2020. Kerr now says there's a mistake in that proof. His argument is roughly the following. Hawking and Penrose used an argument about the length of curves. They basically said in a black hole space-time there are curves which have finite length, and the only way this can happen is if there's a point where they end, which is the singularity. The problem is that the length of a curve is usually related to the time that passes on the curve, which is called the proper time. But for light, no time passes. So for the curves on which light moves, you need to measure the length in some other way. You do this by what's called an affine parameter. If you don't know exactly what that is, don't worry. Relevant is just that the affine parameter isn't the same as time. So why worry if it ends? Kerr now says that the Hawking-Penrose proof draws wrong conclusions from this affine parameter. If the affine parameter ends, that doesn't mean that the curves end at any finite time, because those are two different things. In the example he gives, the affine parameter is an exponential function of time. This will be bounded from below, so it kinda ends, but the curve still continues for all times, so no singularity.
Remember, time isn't something you can use in scientific experiments based on quantum physicists, because time is so relative. It's so connected to where you are, on what planet, where the sun is, how far away it is. It's this is the thing.
In his paper, Kerr doesn't mince words. He writes, why do so many believe that the star inside must become singular at this moment? Faith not science, 60 years without proof, but they believe. It seems to me that Kerr's argument is almost certainly mathematically correct.
So you understand, faith, not science, what they believe. This is words that I've been using in my earlier videos. So just go and take a look at them. It's quite the journey, so to speak. So even the scientists are using equations based on faith and belief.
And it's to the shame of many theoretical physicists, including myself, not even a particularly difficult argument. The question is then what this physically means. There are three things that came to my mind immediately. First, just because the proof that black holes contain singularities isn't correct doesn't mean that the conclusion isn't correct. It might be.
That's a leap of faith, right? I don't think you would get a good score by not showing the way you went towards the conclusion. If the proof is all muddled up, but the conclusion is right. Maybe they cheated.
That this distinction which Kerr pointed out actually tells us something about the type of singularity rather than about whether they're present or absent, and someone else will complete the proof. The second thing to know is that there are other reasons physicists think black holes give rise to singularities which are more on the physical side. Most importantly, if you compress matter beyond a certain critical density, we don't know any force that could create enough pressure to stop it from completely collapsing. And we have numerical simulations for that, though of course those never really create singularities because that'd blow up even the best computer. The third...
Like my computer would not be able to run that simulation. I'm sure of that.
thing to know is that most physicists don't think there's a singularity inside black holes in any case. It's because near the singularity they expect the quantum effects of space-time to become important, but we don't have a theory for that. Though maybe now we do, if you remember yesterday's episode. What's new about Kerr's argument is that he says you don't need those quantum space-time effects to get rid of singularities. Little Albert is mightily impressed by this paper and also slightly amused that so many physicists...
Imagine this is a person in an evangelical thing, and she has a bobblehead Jesus Christ.
But I've been so wrong for so long. Did you know I have a quantum mechanics course on brilliant.org? It's a beginner's course that you can take without any background knowledge. It'll introduce you to topics such as interference, superpositions and entanglement, the uncertainty principle and Bell's theorem. And afterwards you can continue learning more about your favorite topics in science, computer science or maths. All courses on Brilliant come with interactive visualizations and follow-up questions. It's really an easy and fun way to learn something new. If you want to try it out for free, use our link brilliant.org/Sabine. First 30...
This is brilliant. No pun intended, but she is brilliant. And Sabine Hossenfelder. I will link this video in the description, so follow her. Learn something. We need more people that have some kind of an understanding of reality into this field, it seems. Because they're getting caught up in simulations of a theory that is a concept that has been proven with the concept, and the math just doesn't work for some reason. But we're trying to figure it out. While we are sitting in it, in space, and the sun is moving, time is passing. So it makes me wonder, why is one of the worst human beings on the planet financing these people to look at something that is 27 light years away? Is it somebody who's saying, like, look over there, while they're doing something else, right? So I'm wondering, this force of evil is connected to a lot of money. And that money is being funded into people that are watching this, simulating this, doing this. And if you just look at NASA, I think they get $60 million a day, $60 million a day. And I think, what was the budget for Gravity, the movie? It was $100 million. You watched that movie and you were like, yeah, Sandra Bullock is in space. That's so amazing. Science. We believe in science. We believe in science. But I hope I made you think, at least. Or wonder. But thank you so much for watching. And I wish you the most beautiful present moment. It's time to shine. So let's glow.
Gilli Pong.
Analyses stuff.